Hello everyone. Today we have a new job. It's a Lenovo laptop. I think it's a IdeaPad 315 AD. Yep. This laptop came in for repair. As per customer, he said that his laptop is not turning on or booting or giving any sign of life. So by pressing the power button, yeah, nothing happens. Okay. How about we insert the power supply? At the beginning, it's a thin pin. Yeah, I do have it. All right. Did you see? It's trying to boot. It's trying to take power, but it doesn't. Could it be? Yeah. Can you see that? It's taking 0.07 amps. That means 70 milliamps, 50 milliamps, and then drops. That means we have, as I'm assuming, that it can be a short on the main power rail. Maybe. Okay. Let me disassemble the unit and I'll get back. All right, screws are out. Now, should remove the back cover. Okay, back cover removed. Back cover removed. Removing main battery. And let's begin. First, we are going to test the main power rail. Putting my multimeter into diode mode. Probes. One on the negative. And where is the main power rail? Here we have the battery. Yeah, it's a battery input. Yeah, no problem over here. How about this? No problem over here. Where can we find the main power rail? Okay, what's in here? Oh yeah, okay, good. Here we have, let me show it to you a better way. Here we have the input, first MOSFET, second MOSFET, and here we have the current sense resistor. So by testing between ground and current sense resistor, okay, you see, as I told you, there is a short, but there is a problem. If you can see, whenever I test the main power rail, the short is not total. We still have resistance. So the short is not total. We still have some resistance. That means there might be a bigger problem. Let me switch to resistor mode. Testing. We have about 3 ohms, 4 ohms. Usually 3 or 4 ohms, that means it is related to the processor. I hope it's not the case over here, or there might be a MOSFET, shorted MOSFET on the CPU that is sorted on the input or positive power rail that is shorted. If that's so, that means we have a big chance that our processor is dead. Okay, I hope it's not the case over here. Okay, let me remove first the heatsink. So battery is removed, everything is removed, good. Okay, heatsink removed. Now switching my power supply to 0.8 volts. That's the voltage needed uh, for the processor, and about 3.5 amps as current. I think 3.7 will be enough. Okay, now so set it my power supply to 0.8 volts, 3.7 amps. Now trying to find where can be the problem. Of course, heatsink removed. Let me just connect my negative probe. Where can we? Okay, we can put it over here. Great. Do you have a good connection? Let's see. Great. Now, for the main power rail. Yeah, I can see. Yeah, I can see a what? Wait. Yeah. I can see. I can feel some heat over here. So most probably it's not the processor, right? Please tell me it's not the processor. Let me switch to microscope. Now switch to my microscope. Let me apply some rosin. Um, as per the thermal cam, there might be a problem in one of these. Probably this. As you can see, the coil has a little bit of heat. Okay. Okay, enough rosin. Let us apply voltage on the main power rail. Do we see any sign of heat? Okay. So I raised up a little bit the current to see if I can see any kind of heat from anywhere. Well, I don't know if you could see it, but I can see that this capacitor is getting a little bit hot. Okay, now switching to our multimeter. Now switch to multimeter. Let us test this capacitor. So this capacitor shows that we have short. Okay, putting the capacitor aside, now let us test around this capacitor. Yeah, this is the main power rail. So this is the main power rail. As this means that this one is negative. Oh no. No, we still have short. We still have short. All right. So this capacitor is not our suspect. Great. Now, since we are aware that this capacitor is not our suspect, why don't we just test the processor power supply? Yeah, for example, if we test so this one, I think this is the negative. Yeah, so this is a negative MOSFET. That means it is okay because yeah, you see our processor power supply given me that 0.004. That means one of these MOSFETs is affected. Or could it be somewhere else? Yeah. So now the board is out. Okay, remove the board. Let me put this chassis away. Okay. Let's see now. So here we have the power supply for the processor. And on the other side, we can't find that much. There isn't that much. Testing those capacitors. Yeah, this is the same. I'm gonna remove these three MOSFETs one by one. Let me turn camera again. 1 second. Yeah, focused. Right. So I'm gonna remove each MOSFET, and after removing each MOSFET, I'm going to test the board to see if there is short. We still have a short actually. Okay, first MOSFET removed. Let us test main power rail. Yeah, we still have short. Let us remove the other one. Yeah. All right. Now the MOSFET is removed. Still have a short. Yeah, we still have a short. Okay, here we have the third one. And I think this one is for, it's not for the processor itself. It's actually for the chipset. But since the chipset is embedded with the processor, I think uh, if it's defected and it will not work, that means we have a big problem. All right, so MOSFET removed. Trying the main power rail again. Nope, there is something else. Well, actually, that is a good news, huh? That's a good news. Now, since we have removed those three MOSFETs, why don't we do the following? I insert my power supply, which is 0.8 volts. It will not harm my processor, of course, but I will check if there's another problem over here. Actually, my power supply is not beeping. That's a good sign. How about here? There's nothing also. Okay, so inserting power. Now this one is still heating up. Which component is this? I don't have heat from anywhere but here. Is it rising? Yeah, the temperature is rising. We have a spot, a point with 38, 37 actually degrees. Now let me remove my power supply. 35, 34. That means we have a problem over here. Could it be this chip? I tried to make the Rosen to see if we have a problem. It's not the capacitor actually. Could it be the power? The chip itself that's defected? Well, I'm not going easy this time. I'm gonna put my power supply to 0.9 volts, 6 amps. Let's see now. Okay, let me switch my microscope to see if there is any component heating up under the microscope. Yeah. All right, let's do it. Could it be on the other side of the board? There is something heating up also. Wait. I can see a capacitor that's not in a good shape. You see? Now I saw it. Now I saw it. This capacitor is blown. So this means this capacitor is making this problem, or it is responsible of the shortage. Thanks, Samrasan. So the heat was coming from the bottom side and not the top side. Let's see which one of these, or which pole is the negative. Yeah, this one is negative, this one is positive. That means this is the main power rail, a main power rail capacitor. Let me apply more rosin. More rosin applied. Prime voltage. Yeah, you see? Here is our capacitor that's making the whole commotion. Yeah. Let me remove it quick. Yeah, I could see it. But this capacitor is affected in a way you can suspect that there is a MOSFET. Removing this capacitor. Well, this capacitor is defected in a way that you suspect that there is a problem with a MOSFET for the processor. And now, testing the main power rail again. Do we have a short? No. The short is gone. The short is gone. Well, my apologies to those MOSFETs. I just suspect them. Well, they are not the problem. Putting back those MOSFETs. Now, I'm going to insert back boards. First, before doing this, I'm gonna clean the processor. It's an AMD processor, huh? Now I saw it. So cleaning up the processor, cleaning up the heatsink. I'm gonna apply a new thermal paste as usual. Let it dry for a while. Inserting back. I have all the cables out. Everything is up. Okay, great. I should see some arrows. Arrows means I should put a screw over there. A white arrow. No. Applying some thermal paste. Not too much and not too little. You should be a little bit fair about the thermal paste, not to put a lot, or it's gonna be very messy. And you cannot put just a little bit because you will not have a good heat dissipation from the processor to the heatsink. I need to insert back this fan. Oh, needs some cleaning too. Dust. This is dust. Brushing it a little bit. Great. Now, here we have our heatsink. Great. Inserting back the cables. Last but not least, the hard drive. Inserting it back to its place. After that, we insert the battery and we insert our power supply and we see a light and the fan is spinning. Oh, the fan stopped spinning. Okay, but we see a light. That's a good news. Now let's see. Putting back the BIOS battery to its place. Wow, wow. So the laptop booted. Great. The laptop is withdrawing 1.5 amps. That's good. And I see that the battery is charging. Great. Well, let me click on the yes. The battery is read by the EC chip. It's reading it. Very good. It will take about 1 hour 50 minutes to fully charge. That's good. That means our job here is done. Yeah. It all depends on the reading for the repair to be done. As you saw, I was wrong at first because the reading that my multimeters showed that there is a short, but with 0.04 or 3 ohm on the main power rail. The 3 ohm usually would be a processor. Maybe a dead processor could be at 3 ohms or less. But the capacitor that we removed, that was our dead capacitor, gave me this reading, misled me to a processor area, even though my thermal cam said that there is a problem over here, and I couldn't see it because it was on the bottom side of the board. But anyway, at last, the laptop worked again. Everything works again normally. Thank you for watching. Like and subscribe as usual. And thank you for your support. Tell me in the comments what you think about this job. And I will see you another one. Bye.